nothing new. The only new part about it is that it is a curve that is an asymptote so that we approach it and we don't cross it. So let's go ahead and continue on. Let's talk about, do a few examples, graphing and putting all of this together. So let's look at this example. This is the one that was before the reading on the slant asymptotes. I have the rational function y equal 1 over x quantity squared. So again, first thing is, and I'm going to be giving you hints as we go through for the test. First of all, you need to recognize it's a rational function, polynomial in the numerator, polynomial in the denominator. So once you recognize that it is a rational function, then you need to think of the parent rational function, y equals 1 over x. So that should always be in the back of your head. Now, the next thing you're going to want to do is, well, you're going to have to give me all these very important properties of this graph, of this equation, and then we're going to graph it. So if I am looking at, and it doesn't matter what you do first, right? On the test, you're going to have to give it all to me. So let's say we want to go ahead and look at the vertical asymptote. How am I going to identify the vertical asymptote?
Which values of x give
make the denominator 0, and we're going to elaborate on that a little bit more because they make only the denominator 0. A little foreshadowing. Okay, so if I go ahead and set x squared equals to 0, then I get x equals 0. So you would literally say there is a vertical asymptote at x equals 0. On the test, I need that equation. If you don't give it to me as an equation, it is not completely correct because that is the equation of a vertical line. I would at that point go ahead and come to my graph and graph it. So what am I looking at? I'm looking at the y-axis. So I have a vertical asymptote here. At a minimum on your graph, dotted line, write VA for vertical asymptote. Now, what might be the next thing that I want to look at? Well, then the horizontal asymptote, why not? So let's go ahead and look at our horizontal asymptote. How do I determine if it has a horizontal asymptote, and if so, where is it? What am I looking at? The degree. So n, the degree of the numerator is 0. The degree of the denominator m is 2. So since n is less than m, what do I know about the horizontal asymptote? It's at y equals 0. It is the x-axis every time you have the degree of the numerator less than the degree of the denominator. So I'm going to go ahead and label that as well. So I have a horizontal asymptote.
Dr. P?
Yes.
I don't think I can see your screen.
Okay, you might want to leave the call and come back on. Can other people online see the screen?
Yeah.
Okay. Yeah, Shreya's tried to log off and log on. Okay, so now I have my vertical asymptote. I have my horizontal asymptote. Let's see if we can identify anything else that might be of importance to the graph. Do I have any x-intercepts? How can I? Right? The x-axis is an asymptote, so we would say none. What about y-intercepts? There are none. Right? I mean, I know that because those axes are asymptotes, so I'm not touching them. Now, I could go ahead and identify the domain and the range at this point, couldn't I? I could. Do I really even know where this rational function is? No, I don't. Okay? So I could either be, and I'm just generalizing, to the right of my y-axis, I could either be up here or down here. I don't know. With respect to the y-axis, I could either be up here or down here. I don't know. So how on earth am I going to figure that out? Well, maybe I need to create a table of values. So let's go ahead and look at a table of values. Yes, Josh, did you have a question?
Can't you tell if it's which quadrant side is in by looking at the?
I don't see a reflection. I don't know what you're talking about, Josh.
Oh, I see. Never mind. I don't know.
He means like hypothetical situation.
Hypothetical situation, best practice plot points. because that's going to tell you exactly which quadrant you're in. So I'm going to choose an x value greater than 0. I don't care what you choose. What about 1? When x is 1, what is y? Okay, so that's great, but so I know it's in the first quadrant, but I don't really know what's happening. So what if I substitute in, let's say 5? If I substitute in 5, what do I have? 1 over 25. So that means I'm getting smaller as x is getting bigger. So I'm like teeny tiny, 2, 3, 4, 5, right here. And I know that my graph approaches my asymptotes. It hugs my asymptotes. It goes closer and closer to my asymptotes. So I know right here that I am doing this. I'm getting closer and closer, and then that means this one is hugging this one. So really, I just kind of needed an idea of what was going on. Knowing what I know about asymptotes and the graph of my rational function approaching the asymptotes, and definitely never crossing it in the tail, I know what's happening here. So maybe I want to see what's happening on the other side of the y-axis. In other words, is my graph up here or is it down here? Well, let's figure that out. Let's go ahead and look at x equal -1. If x equals -1, what is y? No, it is not. 1 over -1 squared is 1 over 1, which is 1, right? So that means I'm in the second quadrant. Now I could do the same thing and I could do -5 and I still get 1 over 25. So that means I'm approaching 1, 2, 3, 4, 5. This in the tail and then here. Do we see that? There is the graph of my rational function, y equal 1 over x squared. Now tell me, what is the domain of this function? For what x values is this valid? In interval notation, what is it?
Zero, union, 0,
Fantastic. What about my range? Oh, my range.
infinity.
0 to infinity, right? Because I'm only in the first and second quadrants. And I'm not equal to 0, right? I get close and closer and closer and closer, but in the tails, but I never touch it. Now, is this even, odd, or neither?
Even.
And I could verify that if I wanted to by demonstrating that f of x equals f of -x. 1 over x squared is the same thing as 1 over -x squared, right? So it is in fact even. That's what I'm looking for. This is fantastic. Now, they get more interesting, so hopefully you became one with these slant asymptotes and practice it. Let's put it into practice here. So this next example, we want to graph this rational function. So what can you tell me about this? Where do we want to start? Okay, you want to tell me the vertical asymptote? Where is the vertical asymptote? And how do you know that? Mm-hmm. Okay, so let's graph that. So when x is equal to 0, I'm on the y-axis. What else can you tell me? Oh, there's no horizontal asymptote. And how do we know there is no horizontal asymptote? Because n is greater than m. So if n is greater than m, that is implying that I have a slant asymptote. So let's find that slant asymptote. So that means I am dividing x into x squared plus 0x plus 1. Notice I put my placeholder. Okay, so x goes into x squared how many times? Okay, 1x. Right? Mm-hmm. So what is my slant asymptote? My slant asymptote is y equal x plus 1 over x if I wanted to do the division. What am I really paying attention to? This right here, right? Not worried about the remainder. I did the division, but there is my slant asymptote. And I said this is a very important line that you should be familiar with. Y equals x is my slant asymptote. Ooh, look at that. Now I have a lot of possibilities. No.
When we
Now-
state slant, sorry.
I'm sorry?
When we state the slant asymptote on the test, would we have to also include the remainder, or do we just put what it actually is without the remainder?
I would show the division, but then I would show, it'll be a little bit more explicit. You may not have a remainder on the test. So, but this is all I'm really looking for.
I see. Thank you.
Now, I have a lot going on. So, I mean, I could either be to the right of the y-axis, I could either be down here, or I could be up here. I don't know. So I have to check x. And then with respect to the left of my vertical asymptote, I could be up here, or I could be down here. I don't know. So I have to pick an x value that is less than 0. So let's go ahead and do that. So I'm coming up with some additional points. Now, out of curiosity, is there anything else I could easily identify? Yes.
It's off.
You want to,
Oh,
well, why don't we not worry about that just yet, and let's look at some other characterization, some other critical values. Do I have an x-intercept?
yeah.
My x-intercept, remember, is when y is equal to 0. So if I set 0 equal to x squared plus 1 equal x, we know what we know about cross multiplying. I'm really only looking at the numerator equal to 0, right? I'm only looking for the numerator equal to 0. So do I have any x-intercepts? Really?
Oh,
If I square root both sides, I'm taking the square root of a negative number. I have an imaginary part. So really, x is equal to plus or minus I. So am I real? No, my roots are not real. So I'm not crossing the x-axis. So that right there, that information right there says I am down here and I am down here, right? Do you see how I know that? I do not cross the x-axis.
oh,
I have no real roots. So do you know that's where my graph is going to be?
yes.
Okay, now we need a point in each of those regions, and then we hug the asymptotes. So I'm going to choose x equal -1. When x is equal to -1, substitute into the function and tell me what y is.
Wait, -2. You know,
Can I not what?
I thought you can't use -1. Oh. I thought I was.
Do you see that? I know my graph. Look how lovely that is. I'm hugging my asymptotes. I'm approaching it, but I'm not going to cross it.
So we only have to plot that one point.
Yeah, I just need to know where it is, right? And then you hug the, how easy is this? Okay, when x is equal to 1, what is y? Oh, that was a -2, sorry. I said -2 and I wrote 2. So 1, I'm at 2. So what's happening here? Hug the asymptotes, hug them. There's my graph. That's the graph of this beautiful rational function. But let's say a little bit more about it. Do we have any y-intercepts? We know that we don't because our y-axis is an asymptote. Is it even, odd, or neither? Well, you'd have to verify it, but to me that looks pretty symmetric about the origin. So you would verify this, but this is odd, right? So you would need to show f of x equals -f of -x, which is true. Verify that. You should be able to do that on the test. And can you tell me what the domain is of this function? Domain.
-0.
Yes. Good. That's beautiful. Let's try another one. I love these. These are so much fun.
But you love all.
I do, I really do. Okay, what can you tell me about this rational function?
The vertical asymptote is x equals 0.
Okay. What else can you tell me?
There's no
Okay, so there's no horizontal asymptote, and we know that because n is greater than m. So what does that mean? There's a slant asymptote. And can you find me that slant asymptote? Absolutely. So let's go ahead and divide. So I have, and if I were to continue on, I would in fact get x squared plus 1 over x, right? But my slant asymptote that I'm concerned with is right here. What is that? It's a parabola. So can we graph that? That is awesome. So we're hugging. We're going to hug it. Now, what else should we look for? I don't know. Let's look for some intercepts. Do I have any x-intercepts? Again, look to the numerator. Set the numerator equal to 0 to find x-intercepts. So where's my x-intercept? -1.
So that means it can't be this one.
So that means it's there, right? Don't I know that's there because of the intercept? And if that's the case, look, I'm hugging. So to the left of the y-axis, that's where my graph is. But I need to know what's happening to the right of my y-axis. So let's pick an x value that is greater than 0. Let's say 1. If I substitute 1 into f of x, what is y? So that means I'm hugging here. So do you see the two pieces of this graph? The yellow and the black. Do I have any y-intercepts? None. Even odd or neither. That is so neither, it's not even funny, right? But you could verify that algebraically. Now, do tell me, what is the domain? Domain.
Zero.
Positive. Mhm.
Bravo.
Now, that's great. So we've graphed rational functions that have vertical asymptotes, horizontal asymptotes, slant asymptotes. There's another discontinuity, right? Because these are all breaks in the graph. These are discontinuities, right? We have vertical asymptote, horizontal asymptote, slant asymptote, and now we have holes. Literally points that don't exist in the graph of the function. So a hole in the graph of a rational function are generally produced by the factors that are common in both the numerator and denominator. So in other words, you factor the numerator, you factor the denominator. Our initial reaction was to look for vertical asymptotes, what made the denominator 0. That is still true unless it is a common factor and it also appears in the numerator. If that same x value causes both the denominator and the numerator to be 0, sure, we can reduce it. We can cancel them out and give a simplified form, but that is where your hole is. Your hole are the x values, have the x values that cause the denominator and the numerator to be 0. So if you are given the function, you won't be given it in factored form. You'll have to factor it yourself. But let's say we have it in factored form. I'm looking at this and I should notice that I have a common factor. So at this point, I know that my common factor in both the numerator and denominator is x minus 2. So that is implying there is a hole when x equals -2. But a hole is a point that doesn't exist in the graph, that is removed from the graph. So I have the x value. How on earth do you think I'm going to find the y value? Well, at that point, to find the y value of the hole, reduce, meaning cancel out those common factors, and substitute in that x value. Okay, so I'm going to reduce this, and I'm going to get y equals x plus 2. So I've reduced it. That is what's left. Now I'm going to substitute in, and let me go ahead and write this in function notation because, you know, we should. I'm going to call this g of x because it's a new function. I'm going to evaluate g at -2. So that's 0, right? I mean, no, that's not. Yes. This is x plus 2, and then I'm substituting in, yes, 2. So that's 4. Right? Because the common factor, oh, is x minus 2. Okay, so do we see this? So when x is 2, y is 4, that is my hole.
Oh,
I find the x value of the hole. Does that make sense?
oh, because then the denominator
Mm-hmm.
okay,
Let's try another one. Let's factor what we know. Oops. What happened? Oh, it kind of deleted everything. I can't go back. Oh, well. We're still doing this one. Let's factor. I factor the denominator and I see a common factor. My common factor is x plus 2. So I know that there is a hole when x equals what? No. I know there's a hole, right? So my common factor is x plus 2. So that implies that there is a hole at x equal -2. So I'm going to reduce it. I'm going to get g of x equals 1 over x minus 2. And then I'm going to substitute in that x value that I just said is where the hole is. And I get 1 over -4. So that implies that my hole is -2, -1/4. Make sense? Let's try another one.
If the numerator and the denominator both have a common factor,
Mm-hmm.
but the number that like makes them are like
Keep thinking. All right, let's look at the next one. We're going to have to factor the numerator. We're going to have to factor the denominator. Ooh, but I see something nice I can do in the denominator first. So let's factor the numerator. What are my two factors? x plus 3, x minus 1. How do we want to go at factoring the denominator? I'm going to take a greatest common factor out, making it easier to factor. So then I have x plus 3 times x minus 1 in the numerator. Bless you. Let's factor that quadratic trinomial in the denominator to get what two factors? Oh, look at this. I have a hole. So I know I have a hole when x equals 1. So I'm going to look at what's left. And I'm going to substitute in that value of x that I just found. And what is g evaluated at 1? Negative a half. So therefore, I have a hole at 1, negative 1/2. Do we see how to find the actual point? Okay, I told you factoring is with you forever. So let's go ahead and look at another example that has some discontinuities that we're going to have to recognize. So if you are given this rational function, what do we do first? Let's factor. Factors of the numerator. Excellent. Factor the denominator. Okay. Now, you are being asked to find all discontinuities. That means I'm looking for horizontal asymptotes, vertical asymptotes, slant asymptotes, holes. Those are your discontinuities. You have to state all of them. Now, the first one I see is the hole, right? Based on what we just did. So I have a hole when x equals -2, but I still have to find the y value. So I'm going to say g of x equals x minus 1 over x minus 3. I'm going to evaluate it when x is equal to -2. So what's the y value? Not 2/5, 3/5. Do you see how I found the hole? Okay. Now, do I have a vertical asymptote? If so, where is it? My vertical asymptote is at x equal you see that we can't say it is at 2. There is a discontinuity at -2, but there's a hole there when x equals -2.
So after we do the
Find your holes first.
after you find the hole, you can take the hole out. Yeah, so,
You look at what's remaining. Yeah.
Oh, so all the stuff they got left and only use stuff.
No, but that's, you look to the denominator and see what other factors are left, and those will give you your vertical asymptotes. Okay, so then what else am I looking for? Anything else I can identify? Is there a horizontal asymptote? Okay, because I have n is, equal to m, so where is my horizontal asymptote? Y equals 1, right? If the degrees are the same, it's the leading ratio of the leading coefficients. So just for kicks, let's just graph what we know. We know there is a horizontal asymptote at y equal 1. We know there's a vertical asymptote at x equal 3. We know there is a hole at -2 3/5, so that's underneath the horizontal asymptote. That's hideous. -2 3/5. Okay, since I have a hole there, I know where the rest of this graph goes. I know this goes here. If you don't believe me, you could substitute in, well, we could find the y-intercept. What's the y-intercept? Well, the y-intercept is when x is equal to 0. When x is equal to 0, where am I? I did a terrible job graphing that.
Negative two. Or is it negative the third?
One.
Yeah. So do you see that? That's lovely. Now, the question is, what's going on over here? Well, to figure out what's going on over there, I've got to pick an x value greater than what? Greater than 3. So pick whatever you want and tell me where the rest of that is going. Is it above the horizontal asymptote or is it below the horizontal asymptote? When x is equal to 4, what is y?
3.
There's my rational function. Has a vertical asymptote, has a horizontal asymptote, has a hole. Let's try another one. What do I do first? Factor the numerator. Greatest common factor, I'm going to go ahead and take out a 2. Greatest common factor in the denominator, I'm going to take out an x. Factor out an x. I can continue to factor my numerator. What are my 2 factors?
This one's the
I see a hole. Okay, so I see a hole. Where? Negative 2. And what is the y when I substitute in negative 2 for x?
5.
No. I'm removing that, right? And I'm substituting in negative 2 into just 5. So I can graph that. Negative 2, 5. 1, 2, 3, 4, 5. I know I have a hole there. What can you tell me about a vertical asymptote?
Y equals 2. No, just 0, that's the horizontal asymptote.
It's at no,
Or X.
x equals 0. Mia, you're dying to tell me my horizontal asymptote. What is my horizontal asymptote?
That was 2.
So I know this piece of my graph, right? The question is, to the right of my y-axis, am I up here or am I down here? So what do I have to do? Well, I don't know. Should we look to see maybe any x-intercepts? Sure, why not? Do we have any x-intercepts? Remember, that's when y equals 0. So set the numerator. I'm going to set the factored form.
3.
Yes.
Does the line have to go?
The graph has to go up to the hole, not include the hole, and then continue on. Right? The hole is excluded. It's literally a hole in the graph.
Oh, it's, there's, yeah.
Huh? There are 2 roots. Really? You're telling me that my x-intercepts are what? 3, 0.
0.
I'm using the numerator, right? Isn't that what you're doing? Is that what you're doing? I'm technically using this. Oops. But to prove a point, I started here. It's just 3. Why is my x-intercept only 3, 0?
Because it can't go across. Yeah, because there's an asymptote.
Thank you.
Oh, so the other roots just don't count.
Well, I have a discontinuity there at x equal negative 2. Right? It's a hole there. So do I know where this piece of the graph goes? Absolutely. And this is sufficient for sketching a graph. Are there any y-intercepts? No. because I have an asymptote on the y-axis. Is it even, odd, or neither? Neither. I mean, one of your little arms of this, branches of this has a hole in it. The other one does. So, I mean, they can't, right?
So there's a hole on that.
Well, unless there's two holes and they're symmetrically placed.
Is the line going through the hole?
The hole doesn't exist. So I mean, this would be continuous if the hole didn't exist, but the hole is there.
It's like a piecewise function.
So it's coming here, but it doesn't include that point, but it keeps going. This one is not a hole, it's an intercept, so it passes right through that point, right? This point is excluded. It is a hole. It's as if it just was, that point was removed from the graph.
So if there's a hole, the line has to be adjacent to the hole, right?
Well, it has to approach as if it's going to pass through, but it would be omitted. Yes,
Yeah,
yes.
that makes sense.
Domain.
No, and on the -2.
Because there's a hole.
And then a union and 2.
-2 to 0.
-2 comes 0, then another union and 0.
How fun is this? Yes.
You have multiple vertical
Yes.
and horizontal.
Only one horizontal. You're only going to have one horizontal, but you can have multiple vertical. Now, some notation that we've I've thrown in there a little bit, but we really need to familiarize ourselves with is arrow notation. And where this is going to really be important is when you start working with limits in pre-cal and in calculus, because you're going to be approaching the graph from different directions. So we have to understand this notation. You will see this like crazy, okay?
What do you mark it?
Huh?
What do you use
Well,
it?
yes. Yes. All right, so let's interpret this. This is saying X is approaching A, and then that little superscript of plus means from the right. X approaches A from the right. In the next one, the little superscript of the minus sign is saying that X is approaching A from the left. The next notation is saying as X goes to infinity. So as X gets very, very large. So as it goes to the right, as it is increasing without a bound. So that's to the right. And then X goes to negative infinity as X goes all the way to the left without bound. So X decreases without bound. So this is just meaning as we go to the right tail, and this is as we go to the left tail. As X goes to positive infinity, as X goes to negative infinity. Josh?
Does this mean that you can use this notation to write the mean?
No, we write that in interval notation.
It's just like describing where the asymptotes are.
This is approaching where yes, as we approach the asymptotes, absolutely. So let's go look at this. Here I have a vertical asymptote at X equal A. So notice here's my vertical asymptote. In each of these graphs, this is my vertical asymptote. So the graph of the function f of X either increases or decreases as we get closer to the asymptote. So let's take a look. As we approach X from the right, so I'm approaching X from the right side, it goes to positive infinity. This is approaching X from the left, X equal the asymptote from the left. As I'm coming from the left side, it's going to infinity. Here again, as I approach the asymptote from the right, X is going to negative infinity. It's going down. So to be a little bit more explicit, it's going to positive infinity. It's going to positive infinity. It's going to negative infinity. It's going to negative infinity. So we're either approaching a vertical asymptote from the right side or from the left side. As the graph is approaching from the right side, is it going up to positive infinity or is it going down? Now, let's say I have a horizontal asymptote. horizontal asymptote at y equal b. So here's my horizontal asymptote. The graph is going to approach a horizontal asymptote either from up above or down below. Okay? So as it goes to infinity, so as x goes to infinity, so the right tail, where are we going? We're coming to y equals b. And I'm going to say from below. So we're approaching it from below. So I'm adding a little notation there. Now, as x goes to positive infinity, what is the graph doing? The graph is going towards y equal b, but from up above. In the next example, as x goes to positive infinity, where are we going? The graph is coming up to y equal b. Where? From below. Does that make sense? Okay, what I would like you to do, yes. There's more going on in this graph. Remember I said you can cross the horizontal asymptote kind of in the middle, but never in the tail. So that means there's something else going on to the left. I'm only looking at the in behavior. I love that you asked that question. Okay, so this just reiterates it again. Just gives you another example. What I would like you to do is I would like you to use this diagram here and complete this. Complete these right now. And let's talk about them, if there's any questions. Do we think we got it? Okay, in the first example, as x goes to -3, so this is a vertical asymptote at -3. As x goes to -3 from which direction? From the left. So I'm looking at x going to -3 from the left. That's describing this piece. Where is the function going? To -infinity. Okay. Now let's look to the other side of the vertical asymptote at -3. And now let's approach it from the right. So approaching it from the right, what is the function doing? It's going to positive infinity. Do you see that?
Oh, mine's cut off. That's why it's confused.
What do you mean it's cut off?
My packet.
Oh, you don't have this page?
No, I have it, it's just the plus and minuses are, kind of skewed.
They're skewed. Oh, okay, I see. It's blue. It's okay. I understand what you're saying now. I'm sorry. Okay, now I'm looking at this, which is another vertical asymptote at x equal -1. So as I am approaching it from the left, what's the graph doing? Going to -infinity. As I'm approaching it from the right, it's going to +infinity. Do you really need the plus for the infinity? No, but you do need a minus if it's -infinity. So this is going down, this is going up, this is going down, this is going up. Now, let's go ahead and look and see what's happening in the tails. So this is talking about the tails, the end behavior. What is the function doing in the tails? As x goes to -infinity, what is the graph doing? It's approaching 0 from below, right? Yes. Let's look at the right tail. As I'm going to +infinity, what is the graph doing? From above. Any questions on arrow notation? Okay, now, this is going to help you if you need a little reminder on how you're graphing rational functions. It's what we just did. So if you want a little step-by-step, there it is. I have cut this, so this is not on your test, nor it's not there. Just don't even worry about it. I have cut this example, right? So no inequalities. I will tell you right now, there are 2 parts to your spring break extra credit. One of them is to watch this 25-minute video on the YouTube channel and do the My Math Lab. Okay, so that is not on the test at all. I mean, not bonus, no nothing, it's not there. That's your extra credit for your spring break. Here is the rest of the notes packet. So that is on Canvas. You have it here, but it is on Canvas. There's just practice if you want to practice with that, but I've cut it from the curriculum because we don't have time. So if you go to the summary page in your packet, this is not on the test, not bonus, not anything. It's not there. That is your extra credit over spring break. The rest is on the test, and including graphing. So you do need to be able to graph and identify discontinuities in addition to manipulating rational expressions. There are some practice problems. Needless to say, anything that has to do with variation is not on the test. Okay, so if you see variation functions, it's not on the test. However, these last little 3 problems are, and these are on the, because that's rational expressions. Any questions? So I cut variation and I cut inequalities. The variation is an extra credit. Okay? So that should explain what you have in your packet. Now let me tell you about the test. So the test is all non-calculator. All non-calculator. There's some multiple choice. So in those multiple choice, you should be able to be given a rational function and identify discontinuities.
It's on Thursday.
Yes, test is on Thursday. And again, if you're not going to be on campus on Thursday, I need an email so that I can create your test in Canvas for you. All right. Given rational expressions, you should be able to simplify them, which of course involves factoring, right? So lots of factoring. You need to be able to address complex fractions, and I don't care how you simplify them. Turn them into division, multiply by the least common denominator. I don't care how you do it. You should be able to perform operations with rational expressions, meaning multiply, divide, add, subtract. You will also have to, once you do those operations, be able to state any values that would make the expression undefined. So domain restrictions. Then you will have two beautiful rational functions that you will have to identify all discontinuities, describe intercepts, domain, and graph. Graphing includes labeling everything. Colors are nice on graphs. Then you will have a rational equation that you will have to solve and, of course, state the domain or if there's any extraneous solutions. There is There are two bonus problems worth a total of 7 points. So the test is worth 107.
How do we know if something has more than one vertical asymptote?
You'll have two values of x that make the denominator 0, but not also make the numerator 0. So, for example, if you have a rational function, let's say you've got beautiful polynomials and you simplified. You factored, rather. Okay? What's the degree of the numerator? The degree of the numerator. N is, oh heavens. M is, what can you tell me?
There is no horizontal asymptote.
There is no horizontal asymptote. There is a slant asymptote, but no horizontal asymptote, right? Can you tell me anything else about discontinuities? I see two holes, right? One where x is 2, I need to find the y. One where x is -4, and I would have to find the y. To find the y, I'm looking at what's left, right? Now, Amelia, I think you already pointed out, there's something else going on. What's going on? There is a vertical asymptote where? Oh, I meant to give you two x's and, yeah, sorry. So again, sorry.
So the vertical asymptotes are just those that don't make holes.
Don't make holes. That make the denominator 0, but don't also make the numerator 0.
So it was like x minus 2 times x plus 3 times x minus 4. There would be 2, correct?
Change it up a little bit.
It's the same thing.
Oh, golly. I'm trying not to make the numbers too big, but yes, okay, 5. Let's make that a 5, shall we?
Or could it just be like positive 2?
Yeah, I could have done that. Okay, so this is telling me that I have two vertical asymptotes, right? Yes. And then now n would equal 4, m would equal 4. So what do I know? Horizontal asymptote at, right? If I multiply all those together, I have the same degree in the numerator denominator, and the leading ratio of leading coefficients is 1.
Dr. B,
Yes.
Since there's 2, would you just automatically know it's that top and that bottom section? Or, oh wait, no, you can do the outside.
So I have 3 regions I need to check, right? To the left of this one, I can either be here or here. I don't know. For this one, I could be either here, or both, technically, because I could cross that horizontal asymptote in the middle. And then here, I could be either here or here. Not both, right? So I would have to do a little bit of work and choose some x values. I would look for intercepts, right? So, I mean, these get good. And then you have to find me the 2 holes. I mean, these get beautiful. Yes, sir.
If you were inside those 2 asymptotes,